Hi everybody, this is Mr. Ward. Welcome to Unit 3A, Day 7. We're going to start writing some functions when we have some verbal descriptions. So we're going to read them, each one. We're going to set up an equation, then we're going to use our calculator and go back to what we're good at. So the first question we're looking at says, a swimming pool is being drained at a rate of 720 gallons per hour. The table and the graph show the function relating to the volume of water in a pool and the time in hours that the pool has been draining. So the table has some values. X is time. After 0 hours, there was 10,080 gallons. Let's jump down. After 6 hours, there was 5,760 gallons. And after 14 hours, there were no gallons of water in the pool. And we could get the same thing off the graph. The x-axis is the time, and the y-axis is the gallons or volume. And it's going down because the pool is getting drained. So the y-intercept can be found two ways. On the graph, it's easy because it's where it crosses the y-axis, or it's also the value in the table where x equals 0. And so on the graph, you get an estimated value of around 10,000, but on the table, you get the exact value of 10,080. Now we have to say what that means, and it's how many gallons. I could say at time 0, or I could say at the start, because time 0 is when we're starting to, in this case, drain the pool. All right, now we're back to some math talk. H of 10 equals. We love this. We've been doing it for a long time. We put our equal sign, our great wall of algebra, our x equals y equals. The 10 is on the x side. I'm going to go to my table. There it is right there. So y equals 2880. We gave you the y, you give us the x, so circle it. Now let's go to our last one. H of x equals 8640. Again, great wall of algebra. X equals y equals. This time the y is 8640, pardon me. And I'm going to be right up here. The answer is x equals 2 and circle. If I added a little bit on and said, what does that mean? You would say, after 2 hours, there's 8,640 gallons still left in the pool. All right, that was an easy one to start because we gave you the graph and we gave you the table. Next one, we're going to have to do a little more work. It says, Janine has $450 in her savings account at the beginning of the year. That'd be nice. She places money in the account at a rate of $5 per week. That per is bold, and we're going to circle it because it means something. She wants to model the amount of money she has in savings. S as a function of number of weeks she's been saving W. So after 0 weeks, the amount of savings, she hasn't added any money, so she just has the $450. Okay? After 1 week, we're going to do 1 times 5 plus that $450. So she would have $455. After 5 weeks, 5 times 5 plus $450. 25 plus 450 is 475. And after 10 weeks, 10 times 5 plus the 450, $500. We can now graph that. We could say at time 0, when she started, she had 450, and then it goes up by 5s. At 1 is 455, 2 is 460, 3 is 465. That's more than enough. We like 3, I just did 4. If I draw that line right here. Beautiful, there's our graph. All right, so we've got a table, we've got a graph. Now let's explain what S of 6 means. I can draw my great wall down. I can write x equals y equals. I can't go on the table because there is no 6 up here. So I'm going to have to use my graph. If I go over to 6, up, and then over, y equals 480. What does it mean? After 6 weeks, she has $480. And a lot of times, guys, dollars is the Y value. A lot of times. All right, last one. If she saved for exactly 1 year, does that mean 1? No, that would be 1 week. So we're not going to look at 1 on the graph. Rather, we're going to look at 1 year equals how many weeks? And the answer is 52. So we're now going to do our calculation like we did up above. We took the number of weeks, multiplied it by 5, and then added the 450. The number of weeks, sorry, I wrote 50 instead of 52. The number of weeks times 5 plus 450. And on my calculator, when I do that, let's pull up our calculator real quick. Second quit, clear. 52 times 5, $5 a week, plus the 450 she started with, 710. So she would have $710. Be a nice savings account at the end of the year. All right. So our last one, second last one, we got 2 more. We now have to make an equation. There is no table, there is no graph, but we're going to come up with a couple cool things for our rules. Let's read it. The parents of a college student open an account for her with a deposit of $6,000. They then set up automatic withdrawals of $100 from her account per week. So she can have spending money. She starts with $6,000 and she can take $100 out. And if she withdraws $100, what operation do you think withdrawal might mean? Absolutely. Subtract. So now we're going to write a function, and we're always going to do this. Per gets the X. So I see 2 numbers, 6,000 and 100. And 100 is the per. So it says use D for the deposit. And she starts with 6,000. Withdraw means to subtract 100 per week, 100x. Or you could write Y if you wanted to. I suggested you could use T for weeks, for time. We like X. So there's our function. Now we're going to graph it. Let's plug it into our calculator. Let's get a table of values. Clear. Y equals 6,000. Whoops, let's clear everything out. Sorry. 6,000 minus 100x. Let's go to second graph. Let's start at the beginning. 0, 6,000. One, 5,900. 2, 5,800. That should be enough to graph. If you want to do a 4th point, you could. So let's see. 0 is 6,000. I can do that. 0 weeks, $6,000. 1 week, 5,900. Halfway between 6,000 and 5,800. 2 weeks. And if I did 3 weeks, I got my pattern. There's that nice decreasing line, right, guys? It's going down. Because every week when she takes more money out of her account, the balance is going down. There's the graph. Now let's go back to our equation. And we always said the slope is the one next to the x. So m equals negative 100. because it's y equals mx plus b. And what does that mean? Withdraw $100 per week. The slope always gets the per, okay? And then B is the other number, which we said is 6,000, and that's how much the starting amount is. The B is always the start value. How much money will be in our account after 7 weeks? We can use our graph. We're going to go to week 7, up and over. Halfway between 54 and 52 is $5,300. And then the last one, 2,000, it's not on our graph. We're going to have to go to our calculator. So if I go to y equals, clear out the old equation. Oh, I've still got it in, sorry. And we want to do 2,000. That 2,000 is in the y column. I can get there pretty quick. There it is. So I'm going to write my little table down here. 42,000. And what does that mean? That means 40 weeks, after 40 weeks, let's say. After 40 weeks, she has $2,000 left. 40 weeks sounds like a school year, so she'd have $2,000 left by the time the school year's over. All right, 3 for 3. Let's go one more. Shorter sentence, get our equation, answer a question, we're good to go. The cost of a birthday party is $200 plus $4 per person. There's one number. There's another number. I circled the per because that reminds me which one gets the X. So it says the cost, we're going to use C instead of Y. You could use Y. 200, my bad, plus 4x. There's our equation. Once we have an equation, we can plug it into our calculator. Whoops, hit the wrong button. Y equals, clear out the old junk, 200 plus 4x. Second graph. I want to find 324. Ooh, I got lucky. Pops right on my screen. There's 324, 31. So it would be 31 people can attend for $324. We did it just straight in words. If we had another one, we could do some math talk like F of. All right. That's it, guys. Great job today. Good word problems. Day 8 coming up next is going to be the exact same thing, just some more practice, maybe a little bit trickier equations. Thanks, and have a great day.